Hello everyone, welcome to today's lesson. We have already started multiples and submultiple angles in the last class, and we have also discussed some formulas based on double angle, half angle, triple angle, in total multiple and submultiple angles. So today I'm going to solve a few more sums based on those formulas, that is based on multiple and submultiple angles. So here we have the first one. Prove that cos A divided by 1 minus sine A is equals to tan pi by 4 plus A by 2. So let us start the sum from the left hand side. So I have cos A divided by 1 minus sine A. As you can see, the A here has been finally converted to A by 2 ultimately. So there has to be something to be done with half angle formula. Here. So I need to use a half angle formula to convert A to A by 2. What is the formula of cos A? Half angle formula. Cos A can be written as cos square A by 2 minus sine square A by 2, isn't it everyone? Yes, if you remember, this is the formula. So let's replace. So I have a cos square A by 2 minus sine square A by 2. That's the half angle formula of cos A. Divided by now 1 minus sine A. 1 is 1 minus sine A. What is the formula of sine A? That'll be 2 sine A by 2 cos A by 2, isn't it everyone? So let's replace that as well. 2 sine A by 2 cos A by 2, correct? Okay. Great. Now I need to somehow make the formula of tan pi by 4 plus A by 2. That means tan 45 plus theta. Let me write it down here. Tan 45 plus theta. The formula for tan 45 plus theta is 1 plus tan theta divided by 1 minus tan theta. Or I can also write it as cos theta plus sine theta divided by cos theta minus sine theta. That would be the another way of writing the formula if you check it out, isn't it? Because if I convert tan to sine by cos and take LCM, I'll definitely get this one, correct? So from this, whatever I have here, I need to change to pi by 45 plus theta, isn't it? So here I will do something very interesting, okay? So that is, I will convert this one to the identities. What is 1? 1 can we write 1 as sine square A by 2 plus cos square A by 2 everyone? Because I know sine square A by 2 plus cos square A by 2 equals to 1 in trigonometry. That's the first basic trigonometric identity, isn't it? Unless and until I do this, I'm not going to, I will not be able to convert this to tan formula. Let me show you how. This will become now cos square A by 2 minus sine square A by 2, as you all know, divided by, instead of 1 I'll write sine square A by 2, sorry, I'll write just the opposite, okay? Cos square A by 2 plus sine square A by 2 minus 2 sine A by 2 cos A by 2. Can I do that everyone? Yes. Yes, it is possible because cos square A by 2 plus sine square A by 2 equals to 1. By the way, you may ask me why to write just the opposite way. Why cos first, sine second? Because from here, when I factorize, I will get A plus B, A minus B. Cos will be in the beginning and sine will be later. That's why I have also written this in that way. Okay, remember that A plus B whole square equals to A square plus B square plus 2AB. Or I can also write that as B plus A whole square. It's the same. A plus B whole square and B plus A whole square are the same. That's why I can write it in any format that I want to. Okay, so now this can be factorized now, isn't it? Doesn't it look like A square minus B square everyone? Cos square A by 2 minus sine square A by 2. Check this out. Cos square A by 2 minus sine square A by 2. What's the formula of A square minus B square? A plus B, A minus B in algebra, isn't it? So let's use it here. Cos A by 2 plus sine A by 2. Another factor will be cos A by 2 minus sine A by 2. That's another factor, correct? Divided by, now what can I write this? Check this out properly. Doesn't it look like A square plus B square minus 2AB? Cos square A by 2 plus sine square A by 2 minus 2 sine A by 2 cos A by 2. Doesn't it look like that everyone? A square plus B square minus 2AB. The formula is A minus B whole square. So can I write it as cos A by 2 minus sine A by 2 whole square, correct everyone? Yes. So I can cancel the square and one of the factor, and finally I get cos A by 2 plus sine A by 2 divided by cos A by 2 minus sine A by 2. Okay, so I can either write directly, this is the formula for now tan. Okay, we already got the answer. Or dividing numerator and denominator by cos A by 2. If I do that, what do I get? I will get cos A by 2 plus sine A by 2 divided by cos A by 2. Check this out carefully. Divided by cos A by 2 minus sine A by 2 whole divided by cos A by 2. Check this out. Okay, distribute this. Let me show you. Distribute. It'll be cos a by 2 by cos a by 2 and sin a by 2 by cos a by 2. Okay, divided by cos a by 2 by cos a by 2. Then here I'll get minus sin a by 2 divided by cos a by 2. Correct? Check this out, because this cos gets distributed here and here. This cos also gets distributed. The denominator cancel, cancel. I get 1 plus tan a by 2 divided by 1 minus tan a by 2. This is definitely the formula of tan pi by 4 plus a by 2, because as I have already shown you here, what's the formula of tan 45 plus theta? 1 plus tan theta, 1 minus tan theta. Check this out, and this is exactly what happened here. 1 plus tan a by 2, 1 minus tan a by 2, which can be finally converted to tan 45 plus a by 2. So this is how you solve this interesting sum. So in some part, so right in the beginning, I may say, right in the beginning, I have used the formula for half angle formula for sine and cos, but later I have also used some algebraic formulas, and further I have also used some formula from compound angle, which we have learned earlier, because tan 45 plus theta is the formula that we learned from compound angle. So as you all can see that now from now onwards we may have sums which is a mixture of all the previous exercises that we have done as well. Correct? So this is how you solve this sum. Here we have the second sum for today. Prove that tan 15 degree cot 15 degree equals to 4. This is another easy, very easy sum compared to the previous one. Let's copy the left hand side, the LHS. So I have tan 15 degree plus cot 15 degree. So now what I can do here is I have two options. Okay, let me show you both the options here. Either I can do keep the tan as it is and change cot to 1 by tan 15 degree like this, first step. Or what I can do is I can change this to sine 15 degree by cos 15 degree plus cos 15 degree by sine 15 degree. So two options, convert cot to tan or convert to cos sine, both will be correct. Okay, so now I can take LCM here, tan 15 degree, and I'll get here tan square 15 degree plus 1. Okay, here if I take LCM, cos 15 degree, sine 15 degree, both will be the LCM, and I'll get here sine square 15 degree plus cos square 15 degree, because for cos and cos the sine moves up, and for sine and sine the cos moves up, isn't it? So now what can I do here is I can write this as a sec square 15 degree, if you all remember the identity, because 1 plus tan square theta equals to sec square theta, remember? Okay, here I can write 1 and divide it by cos 15 sine 15 degree. Correct, everyone? Because sine square theta plus cos square theta, let me write down here, sine square theta plus cos square theta equals to 1. So I can replace that. Correct? Okay, now what can I do here is I can convert sec to 1 by cos square 15, and tan will be sine 15 by cos 15. Correct? Okay, so here I can write now 1 by cos square 15, check carefully, into cos 15 by sine 15 by making division into multiplication. So one of the cos and cos gets cancelled. I land in 1 by cos 15 degree sine 15 degree. So did I get exactly the same step here? So this becomes a little lengthy, whereas the other one is much more shorter. Okay, so now from here both are same. So what can I do? Multiply both by 2, cos 15 degree sine 15 degree. Why? Because if I multiply both numerator and denominator by 2, this converts itself to a formula. So I'll get 2 by sine 30 degree. How do you know that? Because sine 2 theta equals to sine, let me write here, equals to 2 sine theta cos theta. So here I had 2 sine 15 cos 15, so I can write that as sine 215. So that means 215 is how much? 30 degree. And finally 2 by half, and that's equals to 2 into 2, 4. So that's equals to RHS, and you can say hence proved. Okay, the third sum proved that 2 cos theta equals to under root 2 plus root 2 plus root 2 plus 2 cos 8 theta. So now here if you see, the left hand side is much bigger than the right hand side. So in this particular sum we will start the sum from the right hand side. So we have under root 2 plus under root 2 plus under root 2 plus 2 cos 8 theta, isn't it? So now what we'll do here is we will take 2 common. We'll start from right from the smallest bracket inside and take 2 common. So we will take 2 common from the last square root, and then we get 1 plus cos 8 theta. But can I write 8 theta as 4 into 2 theta? Sorry, 2 into 4 theta, everyone. It's possible to write 2 into 4 theta. Then this will act as an angle theta, and then we can use a formula, isn't it? So I can write it as 2 into 4 theta. Now this looks like, check this out everyone, doesn't it look like 1 plus cos 2 theta? Isn't it everyone? 1 plus cos 2 theta. So what's the formula of 1 plus cos 2 theta? According to trigonometric formulas, submultiple formulas, 1 plus cos 2 theta equals to 2 cos square theta. You may check out your formula. It is equals to 2 cos square theta. If it was minus, then it is 2 sine square theta, correct? So we can replace it under root 2 plus under root 2 plus 2 common with the root, sorry, and then we have 2 cos square theta. Okay, but instead of theta, I'll have to write 4 theta, because here 4 theta acts as theta, correct everyone? This acts as theta here. Okay, so next step, what can I do here is I'll repeat the same process till the square root gets exhausted. Now 2 plus under root 2 plus, here I have under root 4 cos square 4 theta. So what can I do here? I can take out this, remove the square root sign. So I'll get 2 plus under root 2 plus, this will be 2 cos 4 theta. Okay, the same process can be repeated now. So I'll get under root 2 plus under root 2 common, and here I have 1 plus cos 2 into 2 theta. Instead of 4 theta, I can write that. Then the same process, 2 plus under root 2, and what is the formula for 1 plus cos 2 theta? 2 cos square theta, and theta can be written as 2 theta, correct? So repeat the process, under root 2 plus under root 4 cos square 2 theta, and finally I can write it as under root 2 plus 2 cos square 2 theta finally, correct? So slowly it's getting exhausted here. Slowly the square roots are getting exhausted, and then slowly the square root are getting simplified, and we just land in the final 1 square root that we have here. Okay, so same process, finally 2 common and 1 plus cos square theta. Okay, so sorry, not cos square theta, my mistake, there was a mistake here. So this can be written as cos 2 theta, sorry. So finally square root 2 common, 1 plus cos 2 theta, and I can write it as under root 2 into 2 cos square theta, because that's the formula. Okay, the basic one here, check this out. And then this can be written as under root, sorry, okay, 4 cos square theta, and that's finally equals to 2 cos theta. So that's the final answer. And is that what I had to prove on the right hand side? Absolutely, 2 cos theta, and we also got here 2 cos theta. So I can write hence proved. Okay, so let me show you one more time. What did I do? I started from the inside square root, check this out, the innermost square root, and slowly simplified it by using the formula, and then got rid of the square root, and same step has been repeated again and again, same formula has been used again and again, but that way I have just simplified the square root from inside and then slowly reaching outside. What did I get? Finally I got 2 cos theta. Here we have the fourth and the final sum. Prove that 16 cos 2 pi by 15 plus cos 4 pi by 15 cos 8 pi by 15 cos 16 pi by 15 equals to 1. If you observe carefully, every angle here is double of the previous angle. If you check this out here, there's a 2 pi by 15, there's a double of that 4 pi by 15, double of that 8 pi by 15, and double of that 16 pi by 15. The number in front is 16. So let's start from the LHS. Let's see what can we do. Can I separate 2 out of 16? So if I separate 2 out of 16, I can write 16 as 8 into 2. Then I have here sine 2 pi by 15, then cos 4 pi by 15, and then here I have cos 8 pi by 15, and finally cos 16 pi by 15. That's the left hand side, correct? But 2 cos 2 pi by 15 sounds a little incomplete. Instead of that, if it was 2 cos 2 pi by 15 along with sine 2 pi by 15, then I could have written that as sine 2 into 2 pi by 15, isn't it? Which formula did I use here? Sine 2 theta equals to 2 sine theta cos theta. If you have a pair of sine theta cos theta along with 2, you can write it as sine double of that angle, isn't it? So what will I do in the next step is I will introduce sine theta here. So sine 2 pi by 15, correct? Cos 2 pi by 15. Here I have cos 4 pi by 15 left over, cos 8 pi by 15, and cos 16 pi by 15. So what did I do for this sum, everyone? I have introduced sine 2 pi by 15 extra here, isn't it? This is something extra. So in order to cancel the effect, I will also divide it by sine 2 pi by 15, because that way the blue one, highlighted one, the sine 2 pi by 15, sine 2 pi by 15 will get cancelled, and ultimately you got the same thing as above. Okay, but using this will make my sum interesting, because this can be written as, now this can be combined by using a formula. So 2 sine 2 pi by 15 cos 2 pi by 15 can be combined and written as 8 sine 4 pi by 15, if you know that, isn't it? Because it can be written as double of this angle, double of 2 pi by 15. Check this out. 2 sine theta cos theta equals to sine double 2 theta. Okay, now this pairs up with cos 4 pi by 15 and cos 8 pi by 15 along with cos 16 pi by 15, and in the denominator you already have sine 2 pi by 15, correct? Okay, now what can I do is, check this out. From this 8 again I'll separate 2. I can write it as 4 into 2 sine 4 pi by 15 and cos 4 pi by 15. Yeah, I have divided by sine 2 pi by 15 and the leftover cos 8 pi by 15 and cos again 16 pi by 15. So ultimately when I combine this again by using the formula, 2 sine 4 pi by 15 cos 4 pi by 15 can be written as, it can be written as sine 8 pi by 15, isn't it, everyone? Double. But this 4 also in the next step I'll write it as 2 into 2, the leftover sine 4 pi by 15. Can I write that, everyone? Check this out. This 4 is 2 into 2. From here I get 4 pi by 15 left over cos 8, sorry, not 4 pi, my mistake. I can write it as sine 8 pi by 15, isn't it? Double 8 pi by 15. Again, check this out. This 2 by 2 is from the 4, and from this box I get sine 8 pi by 15. Then I have cos 8 pi by 15 and I have cos 16 pi by 15. Correct, everyone? And denominator sine 2 pi by 15. Check this out again. I'll show you with a highlighter. Here 4 becomes 2 into 2, then this becomes sine 8 pi by 15, correct? Okay, next step, what can I do here? I can write it as 2 into, this can be written as, now you have here 2 sine 8 pi by 15 cos 8 pi by 15. Can I combine that and write down sine 16 pi by 15, double of that, along with cos 16 pi by 15, and denominator I have sine 2 pi by 15, correct? Repeat again, the circled one becomes this and the leftover 2. Okay, so again finally, now this is also a formula, and this can be written as sine 32 pi by 15, 32 pi by 15, and denominator sine 2 pi by 15, correct, everyone? So that's how we minimize all this sum, all this product on the left hand side to very simple product now, sine 32 pi by 15 divided by sine 2 pi by 15, correct? Okay, now 32 pi by 15 is quite a big angle. What can I do? I can reduce it to a smaller angle. Let's see how much is 2 pi by 15 and 32 pi by 15. 2 pi by 15 means 2 pi by 15 into 180 by pi. This is how we convert radians to degrees. Pi and pi gets cancelled. We have 5 315, 5 315, and 5 6 30, and 3 12, isn't it? That gives me 24 degree, isn't it? So denominator is sine 24 degree and numerator 32 pi by 15. That gives me 32 into 12. Pi by 15 means 12, and it's 384 degree. If you multiply 32 into 12, you will get 64 plus 12, that's 384 degree, correct? Now that gives me sine 384 degree in the numerator. So now let's simplify this. It's too big an angle. Can I write it as sine 4 into 90 plus 24 degree, everyone? Yes. 384 can be written as 4 into 90 into 24 degree. In the denominator, I have sine 24. Now 4 into 90 plus 24 means in which quadrant does it fall? So that's 1, 2, 3, 490 means here, and plus 24, that's in the first quadrant. And in the first quadrant everything is positive, so I can write plus, and because there is an even number, sine 24 degree divided by sine 24 degree, and cancel it out, the answer is 1. So that should be equal to RHS. Let's check. Absolutely, the RHS is 1, so I can write here, hence proved. So that's it for today. Thank you. Solve the homework sums and submit it on time.